that Venturimeter is an instrument to converge and to diverge the flow and to assess the velocity and pressure proportionality. So, first of all, I have put it that a Venturimeter along with Bernoulli's theorem apparatus set up on the hydraulic bench. So, we are going to have this demonstration in hydraulic bench. Because before going further, as I have already illustrated you, that hydraulic bench is an instrument used to utilize the pressure flow measurements on different notches, gears and different apparatus. So we have utilized this in a pressure velocity proportionality as well. So first of all, hydraulic bench comprises mainly of volumetric tank, storage tank, pitot tube for the measuring in meters. Then it is a switch on and off. Yes. On and off control valve. Remember that clockwise we have to go for that flow which we are going to allow that, and anti-clockwise we are resisting the flow. It is a centrifugal pump or centrifugal machine. These all compartments go to the inlet wall. Inlet wall allows the water to pass through the flow in an open channel and go back to the volumetric tank. There is also a control valve here to control the drain in and drain out of the flow. So now coming back to the Bernoulli's apparatus. Actually we have used the Bernoulli's apparatus to study the Venturimeter flow. Here we already have a Venturimeter. Before going in this apparatus, remember that Venturimeter schematic diagram is like it's allow the flow to a triangular notch, to a triangular setup. It converges it, and through the throat it's going to make that divergence. So here a triangular shape shows that here the water flows in the throat. These are the throats. It converges. Converge means greater the velocity and lesser the pressure. And on the other side, we are going to diverge it back. Divergent means velocity will again lose its space and pressure will be gained. Remember. So what I have done is only I have piezometric tubes here to measure the different heads. A pipe is drawn with each of these heads along with the diameter as well. And here I have put a control valve here in the control valve area to flow the pressure, to allow the pressure to go through this pipe, and then conversion diversion may happen. What I am doing is to switch on the apparatus. Now what I have done is the control valve is basically 0. So I am going to allow the control valve there is also control valve here to control the flow, and it's gaining its head. Now one may remember that always here it comprises of a throat. So definitely here the velocity will be greater, and remember that pressure will be lesser. Here we are seeing pressure is lesser, velocity is greater, because the throat is going to passage this flow in a very slow motion. Now in the first part we are going to utilize the control valve. Now what I am doing is, the pressure is gaining and velocity is lessening in this space. What I am doing is allowing the maximum velocity. Here I am going to allowing the maximum velocity, and pressure is reducing. I am also making sure that both of them make sure that these bubbles doesn't exist in the flow. So what I have observed that if we are gaining the velocity, we are going to lose the pressure. The pressure is going in a very low way. Now to find the discharge, but before going further to the discharge, I am also again in a part 2 going to lower the velocity so that we may gain a now what we have seen, we are discouraging the velocity and the pressure has been raised fully, and now we are again allowing the velocity to go and pressure is low. Why this behavior exists, that it's lowering than the other? Because here the Venturimeter, here the pressure is greater and velocity is lesser. But in the throat section here, the velocity is greater, pressure is lesser. And again, the velocity is decreasing and pressure is increasing again and again. Now for the calculations, we have firstly know the heads difference. We know the head difference and the diameter of that each piezometer. Now for that, first of all, each diameter of the piezometer has been given in the sample or in the manual. In the observation calculation, we may look into it as well. Diameter has been given and Q is equal to AV. Velocity we have to find out, and for the discharge we are going to have now I am allowing again the water to flow. Now, for the discharge, we have given this piezometric tube. We have again overflowed the water. We have allowed the maximum water to flow. Discharge, as I have told you, we have to find V. So for continuity equation, we have Q is equal to AV. So for V, we have to find out the discharge. As the area to be find out by this, as it is a circular pitot tube, so 5/4 will be utilized to find out the area. Yeah. Now we have a drain wall here. Now to find the discharge, remember that it is a pitot tube. When we close that to find out the discharge in the time, it is the volume occupied for the time we are going to find out. Now again I am draining and I am putting it and started the pressure and started the clock. It's gaining its head along with the time clock, stopwatch. So how much time it will take to fill on that with a piezometric tube? It will be a discharge, V by D. And from discharge again we are going to find the velocity, as we have already having A. Remember that to go on further, you may have to sort out the area of each that piezometer tube, and it may be provided on this apparatus as well, but there we do not have any, so we may go for the manual. Now for 10 Then we are going to stop it and we are going to note the time. It's about 8, 9, and 10. It's 1 minute and 58 seconds. So in summarization of this, we are having a Venturimeter to sort out the velocity and pressure difference. We have to sort out the head difference. We are also having to make sure that area exists in the presence of a diameter. We are also make sure that in a throat wall, in a throttle section, our velocity will be greater and pressure will be minimum, as we have shown here in the center. So in the table section, we are going to plot each and every calculations. Thank you.